All right, during photosynthesis, plants use carbon dioxide, water, and light energy to produce glucose and oxygen. The reaction is represented below. Love it. Tying in a little bio. Hope I have lots of you in AP Bio next year. All right, write the empirical formula for glucose. Empirical means reduced. So C6H12O6, I can divide those by 6, and I would get CH2O. That would be my empirical formula. State evidence that indicates that photosynthesis is endothermic. There it is. Energy is a reactant. Or you could say energy is required. Or you could say energy is absorbed, but energy has to go in for it to be an endothermic reaction. So before the arrow, you have to have energy going in if it's endothermic. Okay, fireworks that contain metal salts such as sodium, strontium, and barium can generate bright colors. A technician investigates what colors are produced by the metallic salts performing flame tests. You guys did this. You didn't make fireworks, but you definitely did flame tests. During a flame test, a metallic salt is heated in the flame. Each metallic salt emits a characteristic colored light in the flame. So explain why the electron configuration 2711 represents a sodium atom in the excited state. So sodium atom, you could look up what ground is, and you show that because it is different than ground, it is excited. So ground is 2881. So ground is, I just said that wrong, 2-8-1. So an electron has moved from the second shell to the fourth. So an electron moved from here out to here. So that shows that it's excited. All right, explain in terms of electrons how a strontium salt emits colored light. So as electrons move from excited to ground state, they release energy as light. All right, so here you've got, I'm just going to show you over here. So here we have an atom, and here's the nucleus, and here's the orbitals. And so when energy is absorbed, an electron can get excited. So this could be your flame. And when it gets excited, it moves out to an excited state. So it moves further away from the nucleus. So here it's excited. Here it's at ground. This was absorbing energy. Now, it never stays that way. It always goes back. When it goes back to ground, it releases energy. And when it releases energy, this is the color that comes out. Sometimes you call it spectrum, sometimes you call it color, but it's all the same thing. It's releasing that light. All right. State how bright line spectra viewed through a spectroscope can be used to identify metal ions in the salts. So, each element has its own unique colors due to its electrons. So that was written up here. Each metallic salt emits its own color. So we did that with elements. You could plug in, we had different bulbs that had different gases in them. And when you put them in electricity and you held up the little, the speck to your eye, you could see the lines. So like maybe if you put neon in there, you would see like maybe red and then yellow and then way over here a blue one. And then you put in a different element like mercury and you saw different lines. So maybe you didn't see the red and instead you saw a purple and a blue and a green. So those unique lines are because each element has its own unique colors due to its electrons, what moves and what falls back to ground. All right, show a numerical setup for calculating gram formula mass of reactant 1. So here's reactant 1. I'm just going to go down here to do it. If I have to show a numerical setup for the mass of this, I just want to add up all the parts. So I have 2 carbons. So 2 times, I'm going to go look up the mass of carbon. Carbon is 12.0. So 2 12.0s plus gram formula mass, I got to add everything together. 1, 2, 3, 4, 5, 6 H's. So 6, and then hydrogen is a 1.0. Plus, I have 1 oxygen. So 1 oxygen is 16.0. So that would be my correct numerical setup. If I did all of this math, it would tell me the gram formula mass for that reactant 1. Explain in terms of molecular polarity why reactant 2 is soluble in water. If something can dissolve in water, water's polar. So reactant 2 must be polar to dissolve in water. So remember, like dissolves like. If something dissolves, they have the same molecular polarity. So water's polar, so reactant 2 must be polar. State the class of organic compound to which product 1 belongs. So here's product 1. And I circle what's unique about it. That's its functional group. And then I go over here to table R and I find that functional group. So I want a carbon with a double bonded O and an oxygen in the middle of the chain. There it is. It's an ester. So it is an ester. That's the class. All right, a student develops the list shown below that includes laboratory equipment and materials for constructing a voltaic cell. So state the purpose of the salt bridge. So purpose of the salt bridge has come up in the past few exams. The function of a salt bridge is to transfer ions. Complete and balance the half reaction equation in your answer booklet for the oxidation of zinc that occurs in a voltaic cell. So Zn becomes, and you can look up its charge. Zn is a +2. So there it is. So Zn becomes Zn +2, plus it loses 2 electrons. So oxidation is losing. I've shown that it lost electrons. It changed by 2 and there was 1 atom. So that's 2 electrons. Compare the activities of the 2 metals used by the student for constructing the voltaic cell. So if I want to compare the activities, I got to go to table J because that's the activity series. It tells me how active it is. So I'm comparing zinc and copper. There's zinc, there's copper. So zinc is higher, so zinc is more active than copper. Okay, zinc is more active than copper. Next one. Identify one item of laboratory equipment required to build an electrolytic cell. So this one was for a voltaic cell. What would I need for an electrolytic cell? I'd need a battery. You need a battery because it's a non-spontaneous reaction that converts electrical energy to chemical energy, and that is not spontaneous. So you need an input of energy, so you need a battery for it. My gosh, last page, you guys. Identify the highly penetrating radioactive emission that exposed the photographic plates. So Becquerel discovered that a uranium compound could expose a photographic plate wrapped in heavy paper in the absence of light. It was shown that the uranium compound was spontaneously releasing particles and high energy radiation. So the high energy radiation, those are called gamma particles. And so gamma are like what's in X-rays. And if you go over here, the unique thing about gammas is they have no particles to them. They are only a light energy molecule. There's no mass and there's no protons to it. Complete the nuclear equation in your answer booklet for the alpha decay of uranium-238. So here's uranium-238. You look up uranium's number. So go to the periodic table, and uranium is number 92. So put 92 there. If it is doing alpha decay, go to table O, and table O shows you what to write for an alpha, 4,2-He. Decay means I only have one thing before the arrow, so there's my alpha, and then balance out the math. If you have 238, these two have to add up to 238. So this has to be 234, because 234 plus 4 equals 238. And here, 2 and something equals 92, so this is 9D. And then lastly, look up what element 90 is. So element 90 is thallium, TH. So that is how you would write out your reaction. And then determine the number of neutrons in an atom of uranium-233. So 233 is the mass. The mass is equal to P's plus N's. So if I subtract out the P's, so I just said 92 P's. So 233 minus 92, that's 141 neutrons. That's how many neutrons there would be. Identify the type of nuclear reaction that occurs when an alpha or a beta particle is spontaneously emitted by a radioactive isotope. So we call this decay. So decay would be my answer, but there's a couple other things that you could also write. You could also write that that is a natural transmutation. Transmutation because it's changing elements, and natural because it's spontaneously emitted. So you could call it radioactive decay, or you could call it natural transmutation. All right, you guys, we have just done our 5th practice exam together. Keep following me, keep going through, because we still have quite a few days before this exam. I will definitely be going and putting these on my YouTube. So keep on studying. I know you guys can do this. You are going to rock the chemistry regents this year.